Triangle area using trigonometry. So the do now shows you an old-fashioned area problem with your triangle, a right triangle, and we all know that it's 1/2 base times height is the formula for area, and 1/2 times 6 times 9 is really 3 times 9, which is 27. And that's very simple and straightforward. Now here we have a non-right triangle. We have one side we know is 100, other side is 200, and we have 60 degrees in between them. We call this the included angle, and we really don't know what the height is. We know the base is 200, but the height would be this dimension right here, and we don't know what that is. So we have to use trigonometry to solve this. And there's a nice formula on the formula sheet. K equals 1/2 AB sine C. K stands for the area of the triangle. I don't know why they use the letter K. Okay, but C must be the included angle. Okay, this formula is often referred to as the side angle side formula. You may remember side angle side from geometry. It means you have the included angle between the two known sides, and that's used to prove congruence. You must know the two sides and the angle in between them. Okay, so let's take a look back at the do now, number 2. We're going to use this formula to solve, to find the area of this. So here's our formula. We'll go ahead and designate the vertices, capital A, capital B, capital C. Remember that the vertex has to be capital. In other words, the angle are all capital letters, and the side lengths are lowercase. So that's why I've assigned ABC here, and then the side that's across is lowercase a. So lowercase c goes with uppercase C, and lowercase b is across from uppercase B, just like in geometry. So we'll plug all these in. You get 1/2 times 200 times 100 times sine 60. You should remember, so we simplify this, and you should remember that sine of 60, this is, you've memorized this from the unit circle, is radical 3 over 2. So what's 10,000 times radical 3 over 2? Well, it's 5,000 radical 3. You can check this on the calculator. You plug it all in like this, and 5,000 radical 3 is a match. The answer is 8,660.25 square units. You do number 1. If the vertex angle of an isosceles triangle measures 30 degrees and each leg measures 4, the area of the triangle is blank. Okay, so you need to remember some vocab here. Vertex angle, isosceles triangle. So here's your isosceles triangle where your legs are congruent, and the vertex angle is the angle between the legs. So that's why I've labeled this 30 degrees, and both of these congruent sides or congruent legs are 4. So let's go ahead, and you should recognize that we have side, angle, side. So now we know we can use the area formula that's on the reference sheet. So we plug everything in, 1/2 times 4 times 4 times sine 30 degrees. Make sure your calculator is in degrees mode. We end up with 8. We know sine of 30 degrees from the unit circle is 1/2. And the answer is 4. Let's do this on the calculator to find out if we get a match. And yes, we do. Number 2, in the accompanying diagram of parallelogram ABCD, measure of angle A is 30 degrees, AB is 10, and AD is 6. What is the area of the parallelogram ABCD? Now, as you see, I already split this parallelogram right down the middle, the diagonal, to create 2 congruent triangles. You should remember this property from geometry. So basically, to find the area of the entire parallelogram, we use the triangle area formula, and once we get our answer, we double it. Let's go ahead and use our formula. Plug them in. Sine of 30 degrees is 1/2. 30 times 1/2 is 15. That's the area of half of the parallelogram for just the triangle highlighted in yellow. Multiply it by 2, and we end up with 30. And 30 is the area of the entire parallelogram. Here's your calculator check. We're good to go. Okay, number 3, they don't draw a parallelogram for you. You have to draw the parallelogram. So as you can see, you have 2 sides of a parallelogram, or 24 feet and 30 feet. So 24 is the shorter side, and 30 is the longer side. The measure of the angle between these sides is 57 degrees. So if you had your choice of this angle or this angle, you would definitely go with the acute angle, because 57 degrees is less than 90. So as you can see, once again, we have this side angle side, so we know we can use this formula. 1/2 AB sine C, plug them in. We can't use the unit circle for this because 57 degrees is not one of the known unit circle angles. And we end up with 301.9 is the area of the half the parallelogram, times 2 is 603.8. Sage and Scribe number 1. All right, I already gave it away, but there it is. Here you have a kitchen remodel, and we want to carpet this part here. Carpet everything except for the triangular workspace. So once again, we have side angle side, so we can use this formula. Plug it all in. We end up with 164.2 square feet. They want it to the nearest 10th. Number 2, we have a swimming pool, actually a triangular shaped swimming pool. So here's my artsy picture of a triangular shaped swimming pool. See, here's the ladder, here's a little water. So we know that one side is 16 feet, the other side, the longer side, is 21 feet, and the angle, the included angle, is 58 degrees. So once again, we have side angle side. Perfect. So we'll go ahead and find out to the nearest 10th of a square foot the area of a nylon cover that would fit exactly over top of the pool. Here's your formula. Plug everything in. Our answer is 142.5 square feet. Number 3, Sage and Scribe. We have a parallelogram problem again. Now, I went ahead and drew it. We have 10, 18. The included angle is 46 degrees. It says one of the parallelogram measures, one of the angle of the parallelogram measures 46 degrees. What is the area of the parallelogram? We're going to do the same technique. Plug it in. We're going to find half of it. We multiply times 2, and we end up with 129.48, which is closest to answer 3. All right, last one, number 4. So this one is a challenge. It's double the points. It's really not too tough, but in the accompanying figures, triangle ABC, A equals 10. That's this side, because we know it's opposite capital A. B equals 10. That's this side over here, so we know it's an isosceles. So I went ahead and put in the little dashes of congruence. Find the area of triangle ABC. So we know this length. We know this length. We need to know what this angle is for side angle side congruence. Well, how can we find out what this angle is? Well, we know in an isosceles triangle that the angles opposite the congruent legs are congruent. That makes sense because these are the same length, and therefore these angles open up to the same degrees. If this is 75 degrees, then angle B is 75 degrees. And we know that the angle sum for the interior of the angles of a triangle is 180. So 75 plus 75 is 150. Take that away from 180, and we end up with 30 degrees. So that's how we get our side angle side. Plug these in, 10 times 10 times sine 30. Take the 1/2 of that. 50 times 1/2 is 25. Calculator check. And as you can see, we get a match. Good luck to you.